So this is the section 3 of chapter 4, and it's on constitutional isomers. You'll remember that constitutional isomers are two or more compounds that share the same formula but have different connectivities. So they're put together differently. And they are different compounds. They'll have different characteristics, different conductivity. They'll have different boiling points, melting points, so forth. If we have 3 carbons, we only have one form. So if I've got C3H8, I can only put it together one way. But if I have 8 carbons, I can come up with as many as 18 different isomers. And if I have 10 carbons, there are 75 isomers. So you can see that constitutional isomers are going to be fairly common. When you're drawing isomers, you want to avoid drawing the same one twice. The best way to do that is to name them. You can see here we have 3-methylpentane, and it's drawn 2 different ways, but it is the same compound. Okay, so this is our assignment. For each pair of compounds, identify whether they are constitutional isomers or 2 representations of the same compound. And so that they're drawn, they look very different, but the safest way to distinguish between them is to name them. So let's screen off the others so we can just look at the 2 that we're most interested in. The first thing we need to do is to find the longest chain through here. So that's going to be there or here. Okay, so in each case we have a 5-member chain. We've got 1, 2, 3, 4, and 5, numbered so that the substituents have the lowest number. We'll do the same thing over here. 1, 2, 3, 4, 5. And we see here that we have a 2, 3, there should be a dash there, methyl pentane. So these are both the same compound. If we look at the next one, and again, we need to get the longest chain with the most substituents. So if I do this, I get a pentane. If I do this, is also a pentane. But the blue pentane only has 2 substituents, and the red pentane has 3. So the red one is the right one. We don't want to use the blue one. And we'll do the same thing here. 1, 2. Again, we have a pentane. We have 5 carbons. It looks to me like we want to number it so that we have the lowest numbers on the substituents. So 1, 2, 3, 4, and 5. We'll number this one as well. Let's see. 1, 2, 3, 4, and 5. So if we name the first one here, we get we want to name the ethane first, so we'll do 3. Ethane comes before methane. So it's the 3-ethyl, 2,4-dimethyl. That's these groups here. and then it's pentane. If we're going to name this one, well, it's got an ethyl on the third carbon. It's got a methyl on the second and on the fourth carbon, and it's pentane. So these are the same. They're both the same compound. Let's move down to look at these. So first we need to find the longest chain. So we'll and the longest chain here. We want to number our chains so that the substituents have the lowest number. So we go 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it's a nonane. And this one we would number 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's also a nonane. They both have a isobutyl group. You get a different color. They both have an isobutyl group off the fourth carbon. And they both have methyls off the second and eighth carbons. Trying to pull out another color for the methyls. So this would be a 4-isobutyl. We should put dashes there. Another dash. And then we need to put our dimethyls. It's a 2,8-dimethyl, and it's a nonane. So they are the same. As well. So all these are the same. Same compound. The next section is really short, so I want to try and put it on this video. The relative stability is measured by comparing heats of combustion. So here we have two compounds. They both have 8 carbons, but burned they give off the same number of molecules of CO2 and water, 8 carbon dioxides and 9 waters, but different amounts of heat. This one gives off more heat. And this one gives off less. That means that this one is more stable. So branched compounds will release less heat and are so lower in energy and more stable. So branched compounds release less heat, they are more stable and lower in energy.